Now today's our topic is Bernoulli's equation, which is also called as reducible to linear equation. Now our standard equation of Bernoulli equation is dy by dx plus py is equal to qy to the power n. Now there are steps to solve our Bernoulli equation. Now step 1 is to divide y to the power n from the whole equation. Now after dividing from both sides y to the power n, our equation is 1 upon y to the power n dy by dx plus p 1 upon y to the power n minus 1 is equal to q, and we just call this equation as A. Now step 2 is to substitute v is equal to 1 upon y to power n minus 1, and we just call it equation 1. And step 3 is to differentiate 1 from both sides, so that, and after differentiating on both sides of v is equal to 1 upon y to the power n minus 1, we get 1 upon 1 minus dv by dx is equal to 1 upon y to power n dy by dx, and we just call this equation as equation 2. Now our step 4 is to substitute equation 1 and equation 2 in equation A. Therefore our equation A would be just like this. 1 would become 1 upon 1 minus n dv by dx plus pv is equal to q. Now our step 5 is to multiply the equation A by 1 minus n on both sides. Therefore our equation A would become dv by dx plus p 1 minus n into v q 1 minus n. Now in step 6 we take integral factor and multiply it on both sides. Integral factor is equal to exponent integration sign p dx. Therefore, and after multiplying, our equation would become just like this: exponent integration p dx dv by dx plus exponent integration p dx p 1 minus n v is equal to exponent integration p dx q 1 minus n. Now step 7 is to taking integral on both sides, and we just integrate it on both sides. And step 8 is that we know that the product of integral factor into v is equal to integration sign exponent integration p dx dv by dx plus integration sign exponent integration p dx p 1 minus n v dx. Now step 9 is that we substitute the product formula, and then our equation would be exponent integration p dx into v is equal to integration sign exponent integration p dx q 1 minus n dx. Now step 10 is that we substitute the value of v on the entire solution in the entire equation, and now our equation is integral factor, which is exponent integration sign p dx 1 upon y n minus 1 is equal to integration sign exponent integration sign p dx q 1 minus n dx plus c. Now we are seeing an example of our Bernoulli equation. Dy by dx minus 1 upon x into y is equal to x y square. Now here we can see that this is some extension of linear equation, and when y square is multiplied to this whole equation, then this equation would become as Bernoulli equation, and therefore our goal is to reduce it into linear equation. Now our first step to reduce our whole equation to linear equation is that we divide our whole equation by y square, After dividing, our equation would be 1 upon y square dy by dx minus 1 upon x 1 upon y is equal to x. Now step 2 is to substitute v is equal to 1 upon y and then derivate it on both sides. After derivation, we get minus dv by dx is equal to y the power minus 2 dy by dx. Now step 3 is substitute it in equation 1. Therefore, we just substitute it in equation 1 and multiply on both sides by minus 1. After multiplying by minus sign, we get dv by dx plus 1 upon x into v is equal to minus x. Now step 4 is that we are taking integral factor is equal to exponent integration sign 1 upon x dx because 1 upon x here is our p, and therefore we can write as our integral factor is equal to exponent integration sign 1 upon x dx is equal to, and by solving our integral factor we get x. Now our integral factor is equal to x. Now step 5 is multiplying integral factor on both sides of equation 2. After multiplying our equation 2 on both sides, we get x dv by dx plus v plus minus x is equal to minus x square. Now step 6 is substituting v is equal to 1 upon y, and after substitution we get x dv by dx plus 1 upon y is equal to minus x square. Step 7 is now we are integrating on our both sides, and after integration, as you know that integral factor into 1 upon y is equal to integration sign x dv by dx plus 1 upon y dx, and therefore step 8 is that we substitute our product into the equation. Therefore our equation would be x dot 1 upon y is equal to minus x cube upon 3 plus c. Then we just divide x by our whole equation, and then we get 1 upon y is equal to minus x square upon 3 plus c upon x, and it is the solution of our Bernoulli equation. Thank you.